Hey there, fifth grade. I know that you have received a ton of information from those 4 videos from this week, so I sort of wanted to bring all that together and put it into one place, sort of try to help out with your quadrilateral family trees. So I'm going to talk about 10 minutes or so about how all of these things are related. All right, so first off, we start with our main category, which is quadrilaterals. We always start with the most general category. Right? So anything, any shape that is closed, that means there are no open spots and no curves. Anything that is closed, no curves, has 4 sides, that's a quadrilateral. So anything you could draw that it would have 4 sides, right? That would be a quadrilateral, right? So that's the most general. That includes all of these shapes, right? Anything here, they're all quadrilaterals. But as we move down, we start to get a little bit more specific. So let's move into our first shape. It's going to be the trapezoid, right? What makes a trapezoid a trapezoid? Well, there's one major defining characteristic. That is the fact that it has one set of opposite parallel lines. So this line opposite of that one are parallel. Now, if you remember last year, we did these things to these little arm motions to help us remember what parallel and perpendicular and those vocabulary words meant. So remember, parallel was like this. Parallel lines are 2 lines that continue next to one another into infinity, through a porthole, into another dimension, and they never cross paths. They will continue forever alongside of one another. So if you see these 2 lines here, they're going to go on forever and never cross. These other opposite lines in a trapezoid are going to cross in the not too distant future, probably just above that L there. So a trapezoid has one set of parallel lines. So then we move on to the parallelogram. Right? Now the parallelogram has parallel in its name, so we know we're going to be dealing with some parallel lines. But what makes it different? It's related to the trapezoid because if we look, we've got 1, 2, we've got a set there of parallel lines. The thing that makes a parallelogram different is that it has 2 more. So these 2 lines are also parallel. So on this side, those are going to go on forever. These are going to go on forever, and they're not going to cross. So a parallelogram has 2 sets of opposite parallel lines. This line opposite this one, parallel. This line opposite of this one, parallel. So a parallelogram is a trapezoid because it does have the one set of parallel lines, but it's different because it has 2. So it's related, but it is its own shape. So now let's move on to the rectangle. Right? The rectangle, that's a shape we all know. We see a lot in everything on bookshelves, speakers, books. Rectangles are everywhere. Right? So, shape we're all familiar with. How is it related to parallelograms? Well, if we look, it has one set of parallel lines there, and then one set of parallel lines here. The thing that makes a rectangle different is we look at these little corners, we see these square boxes. If we remember, that means that they are right angles. Right? So all 4 of these boxes, 1, 2, 3, 4, are right angles. They're all 90 degrees. So that's what makes the rectangle different from the parallelogram. See, a parallelogram, it's got an obtuse angle there. That means it's greater than 90. And then up here in this corner, we've got an acute angle, so it's smaller than 90. But rectangle, nice and neat, 4 squared off corners. Okay, so that's what makes the rectangle different from the parallelogram. But it's related because it still has these 2 sets of opposite parallel lines. Okay. Now let's jump over here to the rhombus. Right? I threw on my dirty O's hat in support of the baseball season we can't have right now. So the rhombus is our baseball diamond. Right? The thing that makes a rhombus is the fact that all 4 of its sides are the same length. Right? So not only are those sides the same length, though, they are also opposite parallel lines. So it has 1 set of parallel lines, 2 set of parallel lines. Right? So it is a parallelogram because of that. But it doesn't always have right angles, so that's why we don't have a connection here between the rectangle and the rhombus. But since it has all four sides that are the same, that's how it's related to the square. So now we're going to follow this little connection down here. If we look at the square, right? The square is the mother of all quadrilaterals. It has characteristics of all quadrilaterals. Let's look at why. The square has not one, but two sets of parallel lines, right? So it is a parallelogram. It has one set of parallel lines, also a trapezoid. It has four sides that are the same, so it is a rhombus, and it has four right angles in its corners here, so it's also a rectangle. So the square is sort of the perfect representation of the quadrilateral. Like, as we get down here, we get to the most specific shape that contains parts of all of them. Now, there's one we haven't talked about yet, so we're going to follow this line all the way up here to the kite. Now, the kite is kind of unique. The kite isn't related to trapezoids or parallelograms. Right? What makes a kite is we still got these four sides, but the kite has two sets of adjacent, let me stop there, that is adjacent sides, that means they're connected, right? So it has two sets of adjacent sides that are the same length. So in this little crook of the elbow here, these two lines are the same length and these two lines are the same length. It looks like sort of two alligators having a fight, one with a bigger mouth than the other one, right? It doesn't have opposite parallel lines, any, so it can't be a trapezoid or a parallelogram. However, why is it a square? Well, if you look, a square has two sets of adjacent lines that are congruent or equal. So a square is a kite. Now, not all kites are squares. If you look at this one, these aren't the same length, but some are, and they're squares. Or a kite can also be a rhombus. Well, why? Well, if you look, the kite looks kind of like the rhombus. A rhombus is just a kite that has four equal sides that are the same length. So I hope that clears it up a little bit. But the kite's over here by itself, like I said, because it doesn't have any sets of parallel lines, or it doesn't have to have any sets of parallel lines. So it's not a trapezoid or a parallelogram. Can be a rhombus, can be a square. Square is all of these. And this is how our little family of four-sided shapes works. One thing that I did notice, a couple people have turned them in. They looked great, however, there's one thing in the directions that you missed. For when you make your own family trees for these, I want you to, over here off to the side, I want you to put a major characteristic of that shape. So for instance, for over here next to trapezoid, you would write one set of opposite parallel lines. And you would do something like that for every single shape. So you put a little bullet point here beside your shape. So when you make your family trees, make sure you're putting that extra information in there. Okay? Well, thanks so much, and have a super afternoon, everybody.